very warm and dignified good morning to all of you. Namaskar. I am Nishu Chopra, scientist in NGRI, and I am delighted to be your host for today's workshop. Today, it is my privilege to cordially welcome you all to the inaugural of workshop titled Geothermal Energy Resources of India, Present Status and Way Forward, which is organized by CSIR National Geophysical Research Institute, Hyderabad, as a part of 1 week 1 lab program of CSIR NGRI. We are privileged to have Padma Bhushan Dr. Vijay Kumar Saswat sir, Honorable Member of Niti Aayog and Chancellor of JNU, as our esteemed chief guest. He has graciously accepted our invitation to be here with us, and we are deeply grateful for his presence. His insights and experiences are sure to leave an indelible mark on all of us as we gather here not just to celebrate an event, but also to be inspired by his remarkable journey. Without further ado, it is my distinct privilege to introduce our esteemed chief guest for this event. Dr. Vijay Kumar Saswat is presently Honorable Member of Niti Aayog, Chancellor of Jawaharlal Nehru University. He is retired as Secretary from DRDO. He is a recipient of DRDO Scientist of the Year Award, National Aeronautical Prize, DRDO Technology Transfer Award, and Performance Excellence Award. For his outstanding contribution to the nation, he is a recipient of Padma Shri and Padma Bhushan from the Government of India. He also received the Aryabhatta Award. He also evolved a roadmap for the development of alternative energy systems such as clean coal technologies, high efficiency concentrated solar power systems, and bioenergy and hydrogen-based economy. He prepared a similar alternative energy technology development plan focusing on clean coal technologies and advanced ultra supercritical thermal power plant to work on efficiencies better than 40% and highly reduced greenhouse emission. He is the key scientist in the development of Prithvi, Dhanush, Prahar, Agni 5 missile, and many more. I request you, sir, to come to the dais. Our today's guest of honor is Professor S.K. Mehta, Vice Chancellor of University of Allahabad. Professor S.K. Mehta is a Fellow of the Royal Society of Chemistry, Vice Chancellor of the University of Ladakh, and a Professor in the Department of Chemistry. He has received several prestigious fellowships, including DARD and JSPS Fellowship. He is a recipient of several awards, including Bronze Medal from Chemistry, UK, Haryana Vigyan Ratna Award, Professor Wahiduddin Malik Memorial Award of Indian Council of Chemists. He has made significant contributions to various scientific societies and has been recognized as one of the world's top scientists by Stanford University in 2021. He is credited with 2 patents and more than 376 publications in international journals and is an author of about 25 books. I request you, sir, to come to the dais. Our today's guest of honor is Padma Shri Professor Harsh Kumar Gupta. He is President of Geological Society of India. He is former member of National Disaster Management Authority, Secretary of Department of Ocean Development, former Director of CSIR NGRI, and Vice Chancellor of Cochin University of Science and Technology. He is recipient of numerous awards, including the Padma Shri, the Shanti Swarup Bhatnagar Prize for Science and Technology, Waldo E. Smith Award from AGU. He is also elected as foreign member of the Russian Academy of Sciences. He recently received ISPI Medal 2023 during 28th IUGD General Assembly held in Berlin. He has served as the president of many scientific societies such as International Union of Geodesy and Geophysics, Asia Oceania Geosciences Society, and Geological Society of India. He published more than 200 papers in international journals and authored 6 books, Among those 3 books are related to the geothermal. I request you, sir, to come to the dais. I request Dr. Prakash Kumar, Director, CSIR NGRI, and Chairman of Workshop Organizing Committee to join them on the stage. May I request Dr. Labani Ray, Convener of the Workshop Organizing Committee, to join them on the stage. I would also like to extend a warm welcome to Padma Shri Professor V.P. Dimri, former Director CSR NGRI, Dr. P.B. Sarolkar, retired Deputy Director General of GSI, and all the eminent scientists, researchers, and delegates from CSIR, NGRI, MOES, GSI, ONGC, AMD, and other organizations in the country, and all who are present here today. A warm welcome to all of you. I now request Chief Guest Padma Bhushan Dr. Vijay Kumar Satwar sir to kindly inaugurate the workshop by lighting the lamp. I also request honorable dignitaries on the dais to join them. Join in. This ceremony symbolizes the inauguration and celebration of this workshop. Let this be the beginning of new journey towards the development of geothermal energy in the country, which is a clean and renewable energy source. Thank you, sir. Thank you, ma'am. I now request Dr. Prakash Kumar, Director CSI NGRI, to give his welcome note address.
Good morning, all of you. Respected Padma Bhushan Dr. Saraswat Shah, Chief Guest of the inaugural function of Geothermal Workshop. Respected Padma Shri Professor H.K. Gupta ji, President GSI and former Director CSR NGRI, Guest of Honor. Respected Professor S.K. Mehta ji, Vice Chancellor Ladakh University, Guest of Honor. Dr. Labani Ray, Convener of the workshop. Dr. Padma Shri V.P. Dimri Shah, former Director CSIR NGRI. Dr. Sarolkar Shah, ex-Deputy Director GSI. Distinguished speakers, participants from various parts of the country, scientists, students, press and media. On behalf of CSIR NGRI family, I extend a very warm welcome to all of you to this very important workshop, Geothermal Energy Resources of India, present status and way forward. Let me first express my gratitude and thanks to our chief guest and guest of honor who came here in spite of their very busy schedule and graced the occasion. 1 week, 1 lab is a pan CSR campaign. It started on 6th of January 2023 when our Honorable Minister for Science and Technology, Dr. Jitendra Singh Ji, along with our DG Madam, inaugurated this function from New Delhi. Since then, all the CSR, 37 laboratories of CSIR, started celebrating week-long event, including the stakeholders, society connects, students, and all the stakeholders to whom they work, showcasing their strength, their scientific innovations, their achievements, and also preparing for the future strategies. And CSIR-NGRI's duration for this week-long event is from 4th of September to 9th of September. We had in 5th of September Geoscience Conclave. 6th, we had a stakeholder meeting. And this 7th and 8th, we have a geothermal workshop. And parallelly, we have another program in Chattupal of NGRI, Society and Farmer Connect program. 8th, we have an open day for all the students and general public where we will showcase our achievements to them. And also, I'm very happy to announce that this geothermal workshop is in fact the part of our 1 week, 1 lab program of NGRI, where around 60 participants from different parts of the country are participating on this very important scientific challenges and solutions, and probably will find some solutions for the geothermal energy for future. CSIR-NGRI, in fact, started working on geothermal maybe way back in 60 years before, and a number of works have been done on heat flow studies across this country. And the obvious reason is that geothermal energy is one of the most important, clean, and also abundant. We have an abundant quantity, not only in Himalayan chain, but also in the western part, central India. In fact, that's why our attention has been caught there. But I will say that the exploration and exploitation of this energy in our country is in fact in a nascent state. I take this opportunity to especially thank Dr. Saraswat Sir that with his great initiation, he has organized one important meeting on November 2021 through Niti Aayog and gave a roadmap for all of us to go ahead. Since then, CSIR-NGRI has focused on the geothermal energy and in the Ladakh region and initiated integrated studies, not only in Puga, but also Chamutang and Panamik region of Ladakh. In fact, our field work is still going on in the Ladakh, and we have been also associated with ONGC Energy, where we are carrying out a ERT, electrical resistivity tomography in the Puga region. And Dr. Devas is still in field. He's, I think, returning back. And to accelerate this activity, we had an MOU with Ladakh University, where Professor S.K. Mehta Saab, Vice Chancellor, is instrumental in providing the necessary support in this region. Our efforts would be to meet the maximum energy requirement from these non-renewable sources. And geothermal, as we know, is one of the most important of them. Taking into this consideration, CSIR-NGRI organizing this workshop where the experts from academia and industry are meeting together and will present their R&D works. Total, I think, as I have been said, the 20 speakers, 10 from each day are delivering talks. On the end of the second day, a panel discussion is scheduled where the future strategy on the geothermal will be made. And I think there will be maybe a fruitful outcome will be there, and we will go ahead as the roadmap will be generated. I again take this opportunity to thank CSIR-NGRI for providing this very great avenue to showcase our strength, showcase our expertise to in a week-long events to our stakeholders, society, and students. Once again, I thank our chief guest, Dr. Saraswat Saab, guest of honor, Professor H.K. Gupta ji, and Professor S.K. Mehta ji, and distinguished guests for gracing this occasion. Thank to all my scientists, students, admin people who are associated with this successful organization of this workshop. Thank you very much.
Thank you, sir, for the warm welcome address detailing CSIR NGRI activities and your invaluable support to conduct this workshop. May I request today's guest of honor, Padma Shri Professor Harsh Kumar Gupta, to present his remark.
A very good morning. It's such a pleasure to be here this morning and in the august company of Dr. Saraswat, who has very kindly graced us today in spite of his multivarious commitments. We have Dr. S.K. Mehta, Prakash Kumar, Laboni, who has given impetus to this very important field. Dr. Dimri and several other senior colleagues, students, scientists, and friends. It's indeed a great pleasure that a workshop dedicated to geothermal energy resources of India, present status and way forward has been designed. And it looks to be fructifying. But I had a look at the abstracts which have been submitted. There's a very huge number. And the way all the sessions are planned, I think it's going to be a very useful workshop. Somehow, this resource did not get the required impetus for whatever reasons. There are many known fields, for example, Tattapani in Madhya Pradesh, which is just waiting to be drilled to the depth of about 3+ kilometers and to exploit that resource. I'll try to focus on a slightly different issue today. You see, with the passage of time, what has happened that the availability of water, potable water, has decreased considerably. You all know that 70% of Earth's surface is covered by oceans. But there is only 3% fresh water. Out of this 3% also, 2% is logged in the ice caps and the polar regions. So you are left with only 1% of water, which we keep on recirculating. Now, what has happened that the availability of water, which was about 9,000 cubic meters per person per year in 1989, dropped to 7,800 cubic meters per person per year. And by 2025, it will drop to about 5,000 cubic meters of water per person per year. This is a very serious situation, and we have to look for resources of potable water. And one thing which was done for the first time globally to set up a low temperature thermal desalination plant in Kavaratti. The principle is very simple. The water in tropics, ocean water in tropics, is around 25-26 degrees Celsius around the year. When you go to a depth of 400 or 500 meters, the temperature drops to 8 or 9 degrees Celsius. So if you flash evaporate the surface ocean water, and then you bring the cold water from down below, and in a chamber you condense it, you get the potable water. So the principle was known ever since, but however, in 2003-2004, the National Institute of Ocean Technology in Chennai did an experiment with 5,000 liters per day plant, and that was very successful. That gave us hope to set up a big plant, and one plant was set up in Kavaratti in 2005. This is a 100,000 liters per day plant. Now, in 2005, the calculations were made that if this plant runs uninterrupted for next 10 years, the cost of per liter of water would drop down to about 13 to 12 paisa per liter. That plant is working even today beautifully. What has happened in the process that in Kavaratti, which has a population of about 10,000 people only, the cases reported in the hospitals have dropped to 1/2. The reason being that most of the people are suffering from waterborne diseases. Also, what has happened that when you let out this water from deep ocean into the areas, because you use only a very small percentage, that is full of nutrients. So that has also created very good fishing ground. Now, in the years to follow, 4 more plants have come in Kavarati, but it has not spread the country and all over. I'm saying, take the case, we have got so many rigs in the ocean, and on the platform, you need the fresh water, and you spend a lot of money to get that fresh water from the shore. The same fresh water can be generated on the top of that plant by using this technique. Anyway, I'm very hopeful that this impetus given by this workshop would take it much further. We also need to apply this approach to a lot of water which is generated by all of our urea plants and huge industrial plants, and they are letting out water at 55, 60 degrees Celsius. You can use the same principle, use the fresh water or surface water at 25 degrees and convert into potable water. So I think I'm very hopeful that with the participation of all of you and the kind of these things, it will give impetus, and we will have a better future for geothermal energy in India. Thank you very much.
Thank you, sir, for your informative and inspiring remarks. May I request today's guest of honor, Professor S.K. Mehta, to present his remarks.
Good morning to all present in the hall. And from Ladakh point of view, I'll say Jule. And many of you know that in Ladakh, we say Jule. Respected Dr. V.K. Saraswat, who is chief guest of today's function, Dr. Harsh K. Gupta, Padma Shri, guest of honor, Dr. Prakash Kumar, director of CSR NGRI, Hyderabad, Dr. Labani Ray, convener of the workshop, my dear friend, research institutes, universities, industries, ladies and gentlemen. At the outset, I thank Dr. Prakash Kumar and Dr. Labani Ray for the kind invitation for me to this inaugural function of 2 days workshop on geothermal energy resources of India, present status and way forward. You all would agree that successful landing of the Chandrayaan on the south pole of moon has encouraged Indian scientific community to make India leading world power by 2047. The year we celebrate Azadi Ka Amrit Mahotsav, the Chandrayaan landing year 2023 fortunately coincides with the G20 presidency to India. The UN Climate Change Conference in Glasgow during November 2021 and Egypt during November 2022, countries have agreed for a phase down of use of fossil fuel, that is coal, oil, and gas, as a source of energy. This COP28 is due to be held in November 23 in United Arab Emirates, UAE. At the 26th session of the Conference of the Parties of the UNFCCC in November 21, Honorable Prime Minister Shri Modi has announced that India will achieve the target of net zero emission by 2070. Now, the action plan of SAPCC for UT of Ladakh take into consideration the projected sources of major greenhouse gas emission, climate change impacts, and related assessment. Accordingly, the address of the threat perception through adaptation strategy, the 11 key sectors have been identified for effective action in mission mode. Our Honorable Prime Minister, Shri Modi ji, has set a target to make Ladakh carbon neutral by 2050. To reduce carbon imprint, we need to shift from traditional non-renewable energy to renewable energy within a decade. Since in Ladakh, we have lots of scope to generate energy from naturally available solar energy and geothermal water. Oil and Natural Gas Corporation Energy Center, in coordination with the Ladakh Power Development Department and Ladakh Autonomous Hill Development Council, has already taken phase-wise initiative to generate 1 megawatt of electricity on a pilot plant scale, which shall be gradually be scaled up with accumulation of the substantial subsurface information likely to be generated by deep drilling. The recent ongoing work in Ladakh, Chumangthang and Poga Valley in Ladakh and many other parts of India has opened up new avenues for generating power from geothermal energy. I think NGRI is working in a big way in this area in Ladakh also. University of Ladakh has also geared up with all available resources. As you know, it's a new university just formed in 2019 after the bifurcation of J&K. Recently, we have organized an international conference on various aspects of green chemistry to deliberate on these issues also. And from 19th to 23rd September, we are organizing another international conference on various aspects of climate change in Trans-Himalayan Ladakh. Now, where NGRI is also a partner, along with Wadia Institute, we have GB Pant Institute and NIDM. Besides them, we have a team from Heidelberg University also participating in that conference. So I, on behalf of University of Ladakh, invite all of you, and in particularly our chief guest, Dr. Saraswat, to be chief guest at this conference also, along with all the dignitaries present here. Our team has also started working on MRDP and various other projects in pipeline related to reducing carbon footprints in Ladakh. Department of Agriculture has also been planned in the University of Ladakh as directed by Honorable LG recently, which will help the development of agriculture sector and help towards reducing the dependency of Ladakh on tourism. Because tourism increasing in Ladakh, but that is also affecting the environment as well. UL has also established Mountain Research Institute recently with the help of UT administration. And we have been awarded many big projects from DST like PUS grant or Climate Change Cell, Technology Enabling Center, etc. Several faculty members have been awarded projects in different from different agencies, and University of Ladakh has also signed several MOUs with leading institutes of India and abroad. And one of the important MOU is with NGRI, which directors have also mentioned. And University of Ladakh is committed to become one of the best universities of India, nationally and internationally. And we require support from all sources, even from NGRI as well. The MOU which we have signed between University of Ladakh and NGRI provides us with an opportunity to work for achieving, many targets. For example, in skilling the students of Ladakh, particularly, which have been deprived of the opportunities earlier. So they can, I will request the director that I can send the team of students and faculty here for maybe 2 months or so that they can be trained in a big way and they can do good work in Ladakh also. I hope that the 2 days workshop on geothermal energy would prove to be a stepping stone in the formulating the guidelines for further research in this very, very important area. Once again, I am grateful to particularly the director, Dr. Prakash ji, and Dr. Lavani, the convener, for giving me this opportunity to be part of this very important event. And thank you all and wish the success for this workshop. Thank you so much.
Thank you, sir, for accepting our request in a short time and grace the occasion, and for detailing about your works. I now request our Chief Guest Padma Bhushan Dr. Vijay Kumar Saswat, sir, to present his keynote address.
Sir, may I request the dignitaries to come on this so that you can see the screen? Good morning, Namaskar. It gives me an immense pleasure to be part of this celebration, 1 week, 1 lab. In fact, in the last about a month or so, I think it is the 3rd lab which I am attending this function of CSIR. It's a great initiative, I must say, that these kind of events are being organized to showcase the activities in different labs of CSIR and bringing it close to the society as a whole and also to the industry. So today's workshop or today's discussion on geothermal energy has been one of my very, very favorite subjects for many years. It's not that when I was working in the field of missiles itself, I had thought of working in the area of geothermal, and we did some exercise during that period in 2010-11 to explore some of the possibilities in the Leh-Ladakh region. So that has been the connection what I have. Today, I would like to share with you some of the major areas where we can say what is the present situation as far as geothermal is concerned. As you know, geothermal has recently regained interest globally, breaking out from the niche status. Why I'm saying recently? Because even in the last meeting of G20 on the energy transition, I was the one who got this item included in the priority areas as far as the renewable energy is concerned. I said this should be included because otherwise most of the people were talking of only solar, wind and biomass and all that. I said, why not geothermal? So that is how it got included, which I'll share with you. Presently utilized in increasing number of utility scale commercial projects adopting next generation technologies. And you can see advantage of geothermal that it has got what we call as a capacity factor. Solar is only about 20% wise, wind is only 45%, and geothermal, if you take the capacity factor, is as much as 90%. Similarly, if you see the geothermal, the land footprint per gigawatt hour energy equivalent is minimum as far as geothermal is concerned. Coal is the highest, then solar, then photovoltaics and wind. It can provide us with dispatchable, flexible electricity which is not dependent on weather. It also offers significant resource potential with minimal land use requirements. You are changing or I am changing, or it will change automatically. But it will change of its own.
Acha, okay. So if you see the status of geothermal, presently geothermal energy accounts for just about 0.5% of the world's total renewable energy capacity. Whereas if you see others like hydro, solar, wind, they significantly occupy a larger space. And the countries who have been doing significant amount of work, US obviously is the highest, and Indonesia about 2.3 gigawatts, Philippines, Turkey, New Zealand, Mexico, Italy, Kenya, and by the way, India doesn't figure in this list at the moment. My purpose of showing this slide was only that countries have been working and they have gone to the regions of 3 to 4 gigawatts already, and we have not done enough work in this area. Globally, about 10,20,887 terajoules per year of geothermal energy has been used for direct application in different sectors and replaced approximately 59.6 MBOE of energy and reducing emissions of carbon dioxide by 25.3 million tons. It's a significant number. Of course, the global emissions are in the region of 40 to 42 gigatons per year. In that, our contribution geothermal is only 25, but still it is significant, and it could be for local reasons, it could be very significant. So what are the key sectors which are for the energy pathways? One thing that is happening is the market share as far as this is concerned. Geothermal energy is estimated to grow from about $7 billion in 2022 to about $9.4 billion. That's a significant number with a CAGR of almost 5.9%. Asia Pacific is expected to be the largest regional market in the near future, owing to the increasing investment in geothermal projects in countries such as China and Indonesia. Market growth can also be attributed to the government initiatives, which are basically in the direction of reducing the emissions, that is the whole area. And the high growth of other alternative energy sources such as solar, wind, and gas is expected to hinder this market. When this is happening, people are not worried about the footprint. People are not worried at the moment about how to evacuate energy. But basically, the problem is it is finding it a place in the lower end of the ladder. But what we need to do is by demonstrating better performance as far as geothermal is concerned, we should get into it. Potential for low and medium temperature resources expected to offer lucrative opportunities, and supportive government policies are likely to drive the growth of the geothermal significantly. Our Honorable Prime Minister has made commitment globally now. All of you know the NDC, what we have done. We have said that 50% installed power capacity of the non-fossil by 2030. He has also said that we will have 45% reduction in the emission intensity by about 2030, which is above 2005 level, it's not from earlier levels. And we are also planning to provide a global sink, carbon sink of 2.5 to 3 billion tons of CO2 equivalent through additional afforestation and tree cover. That's the kind of thing. And you know the net goal, net carbon emission to zero is 2070. Now, in the context of this, we cannot say that geothermal will not play a role. It will play a significant role. So what should be our energy transition strategy? It has already been identified as, this is what we presented in the last G20 Energy Transition Group meeting. Clean coal technologies, in which again I have been working for many years now. Unearthing the efficient utilization of the indigenous coal reserves using advanced ultra supercritical systems and IGCC plants, which will offer high efficiency and lower emissions. Alongside, if you put carbon capture, utilization, and storage, then it will mitigate the carbon emissions and greenhouse gas scenarios through the alternative utilization and storage in industrial and energy sector. Actually, industry sector is the most difficult sector to abate carbon dioxide emissions. So that is where CCUS comes. And this is one area, again, NGRI has to play a major role, because if I'm going to do the sequestration, not the utilization part, I need to have a mapping of where are the aquifers, where are the basalt rocks, and how deep I should go for these things for sequestrating the carbon dioxide. And the technology is included in that. How I'm going to do that, because CO2 can also be used for enhanced oil recovery, enhanced recovery of the coal-based methane and things like that. So these are areas where, again, NGRI has a major role to play. Hydrogen, all of you know, you have been listening about it because it's a buzzword these days in the Indian energy ecosystem, which is enabling clean fuel opportunities for the future. And India has launched a hydrogen mission already. You know that, where almost 19,000 to 20,000 crores have been identified for investment, both in terms of setting up the hydrogen parks as well as for R&D. The alternate fuels in which India has been pushing its trajectory is in terms of methanol, ethanol, and ammonia, because these are they are clean combustion fuels and they can be produced from the biomass. The biomass basket can provide this. The new thing which we got included in the latest energy transition strategy was use of nuclear energy. Because if you see, nuclear energy is the cleanest source of energy today. If you compare all of them, even the life cycle emissions, if you take, don't take only the tailpipe emissions, don't take the life cycle emissions. If you take the life cycle emissions, even the highest polluter, you know who is that? Solar power. It gives you 38 kilograms of carbon dioxide for 1 unit of power. That is the kind of emission is there. Whereas nuclear power is only 11. Wind power is only 12. That is the kind of numbers. So we have a very myth which is going around that the solar, in terms of there is a cleaner. Yes, it is clean so long as you look at it only the tailpipe kind of emissions. Mobility is another area where vehicle electrification and exploring the opportunities of the hybrids, fuel cell and alternate fuels have been identified as part of the energy strategy. In the area of energy and storage systems, you can see I got it included, wind, solar, ocean. Ocean was also being omitted today. What you mentioned, sir, about this has been done. Biomass and BESS, pump storage, hydro, again, pump storage systems, hydro for this, that has to be done with indigenous application. These are our strategy in which geothermal is figuring in a big way. So we want to have at least 10 gigawatts of geothermal energy by 2030. That should be our endeavor. If that is the case, then energy deficit in India, which has been in April 2022, clocked about 2,750 million units with a peak power deficit of as much as 8.6 gigawatts. So considerable amount of low and medium enthalpy hydrothermal resources is present and can address energy crisis alongside environmental pollution. This diagram which I am showing here is the NGRI diagram, which I picked up from one of your reports, which indicates what are the possible areas where we have good geothermal reserves available. And I think, I don't know, because it's one of the older ones, probably you would have updated it now. So probably if it is there, kindly share with me. Out of the 400 thermal springs in the country, 150 are present within the Himalayan geothermal belt, with temperatures varying from 47 to 87. Again, this is one area which we need to correct, because my experience was in the last well which we dug in Chuntang Valley, we got steam at 120 degrees and with a pressure of as much as 16 bars. So it was a fairly good spring which was evolving. It went high up, it was like that. So I think gentleman is here. He has been responsible for doing that exercise with Thermax and DRDO at that time. Country is presently utilizing about 4,010 terajoules per year of thermal energy for direct heat applications. I have seen the army units digging small wells and then taking that thermal heat for heating and things like that. But mostly it is a very, I would say, ad hoc arrangement which is being done, not technologically properly done. So Niti Aayog, as I mentioned in earlier by Dr. Prakash, that we have carried out some study, and Niti Aayog along with the CSIR and NGRI, GSI, ONGC, we carried out some study and a report was presented. The idea was to give a mission mode approach as far as geothermal energy was concerned. So we were expecting that these institutions would be able to take it forward, and I bank on NGRI they should take this as a mission. Don't think that is energy and geology research doesn't have anything to do with energy. In that mode, I think you should take this as a value-added product, and NGRI should become the center for geothermal energy in the country. I urge you. Now, there are different technologies which are used in the geothermal power plants, and like direct steam power plants, where a generator, you take the steam from the well, run it directly through the turbine, then send it through a cooler and put it back and connect it to the load. There's flash steam power plants where you take the steam or water from the tank, put it in a flash tank, then vapor will be driving the turbine, and then generator will be connected. Then there's a cooler and it goes back into the system. The main thing that would work on low temperature systems is a binary cycle, where you can use low boiling point liquids, organic liquids, amines and things like that, like hexanes and all. So they can be taken, then there's a closed circuit. You pass it through a heat exchanger where the vapor is vaporized, the organic liquid is vaporized, and that vapor drives the turbine and then comes out to the cooler and put it back. So it becomes a closed circuit. And the liquid which is coming out goes back into the well. So this is a very, in fact, I request some, you have IICT, you have other laboratories together, work out the right parameters for the binary cycle, which is the right fluid. Somebody was mentioning about some of the fluids like arts and all that. So work out the right fluid combination, what gives you the maximum efficiency, what should be the input temperatures, so that we get a maximum. One of the major reasons why the geothermal has not been considered so much, because the overall efficiency of geothermal turns out to be in the region of 10%. Which is one reason why it has not been actually picking up. But the fact remains, even with the 10% overall efficiency of the system, the cost of per unit electricity production is significantly lower. So it becomes viable, and that's the point which we should cater to and work upon. This is a typical binary power plant. I don't think I should go into details, but I think there are two cycles. One is the organic Rankine cycle, which I tried to describe. Another one is a Kalina cycle. Kalina cycle is shown in the green, and the organic cycle is shown in the bluish green, the parrot green. So you take the water from the production well, put it through a filter, then put it through an evaporator, and in the evaporator, from the evaporator, it goes through the Rankine cycle operation or in the Kalina cycle. Finally, turbine generator and so on. So this is a technology I request that somewhere in the CSIR, these two technologies should be demonstrated on a lab scale so that these parameters can be taken for commercial application. As on today, all of us have studied this even in our engineering college. But the parameters which are actually required for making these cycles efficient, we need to be developed, and this work should be taken up. Next generation geothermal technologies are enhanced geothermal systems and the advanced geothermal systems. These are the two things which are emerging today. We take a conventional hydrothermal systems in which there is a convective flow at some depth of 2 to 4 meters, kilometers deep, and that is the below the impermeable cap rock. Then you have a geothermal well. So from there you take that, and basically it is like the permeable reservoir what you have in the system. Enhanced geothermal system, basically we are looking at 5 to 7 kilometer deep kind of a drilling. And in this, you will take some injection well, and through that you will again bring out the material. So that is the thing. Third one is a deep closed loop enhanced geothermal system in which no stimulation, location independent, dispatchable, scalable, base load decentralized, and it is a closed board. It is not open like the other ones. So you can take it back. The aim is to create conditions for geothermal energy in the otherwise impossible areas, and the potential to unlock geothermal energy for many, many countries. What are the current challenges? These are most important because your workshop should certainly debate and discuss how to overcome these challenges. The challenges are, first, the institutional challenges. One is the limited R&D center, as I mentioned to you. One of the major things is R&D has not been done extensively, which is important. Educational institutions, I'm very happy that Ladakh University is working in this area, but I want this work to be across many universities in the country, at least the Himalayan region countries, the regions where geothermal energy are very high. It should be made part of the Himalayan region mission. That should be made part of that. Lack of industries with expertise. That's another one. In fact, when we were trying to dig the well in that place, what is that, Chumtang Valley, I remember Thermax saying that we'll go to Iceland, get the technology from there. We'll ask Israel to give us the technology. All that just for drilling the well. I said, NGRI has done for so many years. Why are you doing that? I didn't allow them, and they did it themselves at the time. So this kind of an understanding with the industry that they don't have technology, that has to be removed by NGRI itself. Then the policy and regulatory challenges are there. Lack of regulations for project environmental assessment and tax incentives are missing. Energy sales and purchase agreements are also not there. For example, even if I produce energy in, say, Ladakh, now Ladakh, even today, I think 90% of the energy is provided by the standby generator sets. Am I correct? Now, in a situation like that, when we dug the well in 2010-11, the transmission lines were itself not there in Ladakh. Now, of course, the transmission lines have been laid. Evacuation of power at various geothermal wells, if you are going to make, up from Chumtang Valley to Nubra Valley, you can have the complete band. How many you can dig depends upon your capacity. Directly connected to the grid, the armed forces who are presently using the diesel generator sets, they all can start using this. There's a power requirement is quite high for heating, cooling, their equipment and all that. They've got radars which use megawatts of power. And they're all dependent upon diesel generator sets which are polluting the atmosphere. So there is a huge case for it. Financial challenges are there where high initial investment. Yes, initially you need to invest money, but it is nowhere compared to other sources. For example, the investment in the wind energy is much higher than the geothermal energy. So you should look at that. Some digging, of course, requires some machinery, costly machine, limited financial support for R&D, lack of knowledge in financial institutions, and high pay. If you go to a bank today and say, I will do a geothermal project, he won't touch you. He says, "Humko nahi malum hai. Please don't, the risk is too high, I can't give you." That's the kind of a situation. So we had to actually educate people. And if we don't do that, we are not likely to succeed in this whole mission. The technology challenges, I mentioned a couple of technologies, they need to be demonstrated. The codes are missing, standards are missing. So all this can be done only if you have R&D. If you do R&D, you will be able to set up those codes. Then educational and awareness challenges, I already told them. Local commodities and government bodies have to be educated on this particular matter. The environmental challenges are also there, like depletion of the groundwater. Many people feel it will be so, but I personally don't believe in this because we are plowing back the water back into the earth. Land subsidence, water bodies, contamination. These are not very serious issues as far as I'm concerned. They are identified, but they are not a major challenge. Now, what are the other global barriers? There are two things. One is the direct geothermal use. Another one is the geothermal power generation. Direct use is for heating, cooling. So in the case of direct use, medium and low temperature hydrothermal resources are relatively abundant and can be developed almost like the army is doing for their sauna baths and all that today at places. Drilling technologies for developing medium and low temperature reservoirs are well established. I think NGRI is the key in that. Geological district heating for GHPs costs more than the conventional heating cooling solutions. Various supporting policies have to be required. If you take solar energy and then do heating cooling using that, apparently because of the low cost of solar today, the geothermal finds it difficult to compete. It's a question of scale. The solar has gone to a very large scale today, both in terms of production of the input materials like the cells and the modules and so on, whereas geothermal is just starting as a thing. So scale is very poor. So comparing these two costs will, but if you do the geothermal also at a scale, I'm quite certain that you will get the necessary benefits. Limited consumer paying capacity as on today. Geothermal power, high temperature hydrothermal resources occur in few locations. What you're talking of 120, 140, these will be at limited locations. They cannot be at all places. Lack of advanced technologies for drilling under high temperature and pressure. I do not know. This you will be able to guide me on this. Is there a problem? Because we are doing oil wells, we are drilling, we are doing so many things which are, when the gas comes out, it comes out at very high pressure and there are temperature issues there also. So is why this has been identified as a major bottleneck, I need to be answered. Lack of EGS technologies for HDR exploitation. High installation costs, lack of economic incentives, and concerns or damage to hot springs tourism resources. These are not very serious things. I think we can, because the footprint is very small, this will not make a difference. Now, innovation is needed to make it geographically applicable. What are the kind of innovation we need today? If you take the resource temperature, 120 to 175, 250 to 300 and 400 on one side and the commercial viability, we find that the conventional high temperature resource, which is the highest, then comes, of course, the conventional low temperature resource, then the dry hot rock, and the extremely dry hot rock, which is very high, which is the highest. So the line is, there's a minimum line, which is marginal line. Above that only it becomes viable. In that case, if you have issues which are there, you will have to do certain amount of funding. In my opinion, the first one is currently deployable. The other two are development in progress, and the hard rock thing, development in progress, local term long-term commercialization is required in that. So what are the critical research areas? And I think this should be of major importance as far as NGRI is concerned. You have, what are the stimulation, planning, and design? What does it mean? It means research that supports efforts to design and optimally stimulate a well in accordance with natural subsurface characteristics. This will require core R&D actions in the develop new well configurations and well field designs. Develop new and adapt existing fracturing technologies and procedures for the EGS, enhanced gassing. When you take off fracture control, you need research that supports efforts to develop optimal fracture network, as well as increase understanding of the resulting fracture system. And what are the actions in this? Optimize design of fracture procedures, develop alternative injection practice and procedures, and stimulation types have to be identified. Develop methods for successful zonal isolation. When you have to look at reservoir management, one has to research that supports efforts to sustain long-term heat exchange in the system. Then, of course, we need core R&D in the area of predicting and monitoring the changes in the fracture system and engineer solutions to compromise or other unwanted changes that has to be looked at. Some more are there, like in the case of quantify vertical and horizontal stress at high resolution, correlate well-borne stress measurements beyond the well-borne, correlate in situ elastic rock property measurements and reduce uncertainty. Fracture control, we have to predict induced seismicity, predict changes in the permeability, volume, conductivity, and other factors. Conduct real-time in situ monitoring of key variables. In reservoir management, we look at permanently installed monitoring instrumentation is required. By the way, instrumentation today has improved so much that you can do it on a non-contact basis, you can do it through tele, you can do it on direct contact. I think all of them should be utilized today. Develop active reservoir management processes and resolve fracture connectivity. So these are some of the research areas which we need to develop. As I mentioned, innovation will take us closer to our thing in terms of terawatts of super hot rock geothermal energy. And that would be confluence of innovation in geothermal oil gas, 2020 commitment to invest billions globally in SHR deployment. 2030 to 2040, we should go for super hot, should be de-risked. We should commercialize demonstrations up to 50 to 100 megawatts, commercial development of deeper heat, and global adoption of the gigawatt facilities. And ultimately, in the end, beyond 2040, 2050, we should have super hot rock energy serves global population centers. That is the area we should focus on. The future is hybrid. That means we should integrate the geothermal energy with other renewable energy sources. Geothermal is poised to help intermittency of the renewable energy like solar and wind. So communities can create their own microgrids. For example, if I take Chumtang Valley, and if there is a solar, like Ladakh also is going into solar plants nowadays, a lot of effort is there. Can I not integrate geothermal with solar and come use this as a base load application? And all the, so that's the diagram which is showing here. Microgrids provide reliability and resilience against energy supply chain. And they also have the potential to create local jobs that will also decarbonize the grid completely, because today we are using the thermal power for the base load for the grid, which is nothing but again a carbonized system. So the full potential is both in terms of power generation, hybrid technologies, direct use of heating and cooling, then solute separation, storage of this energy, carbon dioxide capture directly from the air, and then you can use it for this application. CO2 sequestration can be done directly. So, as far as I'm concerned, I'm in NGRI. So certainly NGRI is at the forefront for realizing the just technologies for transition. It has made an indelible mark in the scientific, academic, and social landscape of India through R&D, innovation in the area of geodynamics, earthquake hazard, and natural resources, water, minerals, and energy, what Dr. Harsh was mentioning. As geothermal exploration and development extends to less understood resources and regions, targets carry high risk and demands placed on geological methods. And geophysical methods are an integral part of the framework, including surface geological mapping, geochemical sample collection of analysis, well data analysis, modeling of the subsurface, thermo-hydromechanical coupled processes. CSIR and NGRI can cater to the geophysical research and future research efforts are designed towards deeper and near surface explorations, which are critical to understand the processes responsible for shaping Earth's structure and dynamics and for subsistence of life on Earth respectively. I'm sure that with its chartered vision and mission, CSIR and NGRI will play a vital and pivotal role in coming years to fulfill the aspirations of the nation, particularly in the area of geothermal energy. I thank you very much and wish you all the best for all your future activities. Thank you, sir. Namaste. Hello. Hello.
Thank you, sir, for inspiring keynote address and describing the status of geothermal globally and lighting on the energy transition. Now releasing the abstract volume. We have to release the abstract. Thank you, sir, for inspiring keynote address and describing the status of geothermal globally and lighting on the energy transition. Thank you, sir. Now it's time to felicitate our guest. May I request Director NGRI to felicitate our chief guest, Padma Bhushan Dr. Vijay Kumar Saraswat, sir.
We should give a standing ovation to our guest. What a brilliant job.
Request Director NGRI to felicitate our guest of honor, Professor S.K. Mehta. I request Director sir to felicitate our guest of honor, Professor Harsh Kumar Gupta, sir. Thank you, sir. Now there is an introductory talk by Dr. Labani. Yes, sir, you can sit down, sir.
Adesh. Sarakopar.
Very good morning to all of you. I am
introductory talk, but after Saraswat sir talk, I feel he has covered all the things. So maybe now my talk will not so interesting, but anyway, I have prepared, so I am giving the introductory talk. So I am telling about the geophysical method for geothermal energy exploration with special reference to the thermal studies. Geothermal energy is the energy produced from the Earth's heat. It is a renewable and clean energy. So our mother Earth formed 4.6 billion years ago when it was a hot chunk, and that time surface temperature was around 2000 degrees centigrade. At present, surface temperature is around 15 degrees centigrade. So the process is mainly due to the cooling. And at the center now temperature is around 6000 degrees centigrade. And now also it is getting cooled and heat is coming out from the surface of the earth, and that is the heat we will use for the geothermal. But what are the processes inside the earth? Inside the earth, the processes are different. It depends upon the composition. So in core it is mainly conduction, in the mantle it is convection, and in the crust and the uppermost part, that is lab, it is known as it is also conduction. So the heat what is coming out is mainly composed of the two parts, but one is the internal and secular heat, which constitute around 40%, and another is rock radioactivity, which is 60%. And due to the heat coming out from the surface, temperature gradient is produced inside the earth. But if we see the last figure, the temperature gradient is different in the different area. That shows temperatures versus depth plot. But if we see the upper part, the temperature gradient is the maximum in the uppermost part and the uppermost mantle and the crust. And our interest is mainly uppermost part of the crust. The temperature gradient in the crust is generally 25 degrees centigrade per kilometer. But when it is few-fold more than that, then only it is useful for the geothermal study or geothermal energy exploration. So here, in general, geothermal sources are two types. One is hydrothermal system, another is hot dry rock system. In the hydrothermal system, the strata should be permeable, porous, and with a cap rock. In the presence of fault and fracture, should be there. And here there is natural water circulation. But instead of hot dry rock system, which is also known as the enhanced geothermal system, there it is impermeable and low porosity crystalline rock. There is no fluid circulation. So we have to do the fracturing of the zone and injecting cold water. Source of the hydrothermal system is magma, most of the cases deep-seated magma. And in the hot dry rock system, it is radiogenic heat production of the rocks. In terms of the enthalpy, there are three types: high enthalpy system, medium enthalpy system, and low. High and medium enthalpy system generally used for the power production, and medium to low enthalpy system used for the different purpose like heat pump system, space heating, refrigeration, and many small scale industry also. So for the geothermal exploration, there are two things. One is regional exploration and local exploration. In regional exploration, we cover large area to identify possible geothermal resources and assess their size. In that, there is surface exploration first we have to do, and then we go for the exploratory drilling. Surface exploration, our aim is to find the possible geothermal resource and roughly assess their size. In the surface exploration, there are different steps. Although always all the steps are not followed, but in general, first it is the surface manifestation, which sees what is the different hot spring or mud flow and its temperature, flow rate. And then we will go for the geological exploration, where we see the structure, lithology, volcanic history of the source also. And then we go for the geochemistry, where we get the abundances of the minerals and water type, whether it is magmatic or meteoritic, and then estimate the reservoir temperature, which is also very important. And after doing this, we have some idea about that area, then we go for the geophysical exploration. In the geophysical exploration, We first do gravity, magnetic, and resistivity. These three methods gives the structure of the source and in the different way. And then whenever necessary, if it is earthquake prone area, we should do the microseismicity, and if required, sometimes we do the seismic reflection also. And after doing all this method, we have some idea about the structure, and then we should do the thermal study like radiogenic heat production and thermal conductivity of those area to find out some other parameter which will be useful for thermal modeling. So after this surface exploration, we go for the exploratory drilling to characterize the reservoir detail. In that, we first initially do the shallow deep borehole like 100-meter deep to get an idea of the borehole. Several borehole generally we should do, and then based on that result, we should go for the deeper borehole. And when we complete the regional exploration, we have complete idea about that area. Then we should go for the local exploration, which is very much critical. And the local exploration, we almost do all the methods again to find out the exact location where should we target to get the maximum energy. In India, from the last 50 years, this year it is going to be 50 years, geothermal studies has been done, and 10 geothermal provinces has been identified. GSI and NGRI both had been worked in 1970s and 1980s. They had been working very extensively, and 10 geothermal provinces has been identified. And among that, 5 area which I marked by red, last 1 decade again some emphasis has been given to study in this area geophysically especially. Now I will tell about the Puga Chamutang, the previous main finding I have wrote. There are many findings. So here water is from the hydrochemistry, water in the Puga there is some confusion. Some studies told magmatic, some studies told meteoric. In the Chamutang it is meteoric water, and the reservoir temperature is also estimated from the chemicals. And thermal studies has been done, and which shows that at the highest temperature in the Puga, bottom hole temperature is around 140 degrees centigrade only at 60 meter, whereas in Chamutang also at 100 degrees centigrade at 220 meter. And temperature of the hot spring in those area is 70 to 80 degrees centigrade. In the Puga, there was temperature measurement also done in the borehole of 1 meter to know the particular thing in the subsurface. In the magnetotelluric studies, this is also done by NGRI, shows that there are 2 conductive zones. One is at the shallow around 400 meter, and one is at the deep 2 to 8 kilometer. And in 2021 November, there was some meeting with the Niti Aayog, and Saraswat Saab has encouraged NGRI and GSI to again work vigorously in the geothermal field, as he told in his talk also. And then NGRI have started again in the Puga Chamutang area, and also we have added one more area, that is Panamic area. So we have started these studies: geological structure, hydrochemistry, gravity magnetic, drone magnetic, rock mechanics, magnetotelluric, and thermal study. And now all the studies are in process, but I will show whatever some result came. In the thermal studies, we have revisited all the area, and we found the temperature is ranges in the same range. And that is interesting that in 1917 and 80s, whatever temperature exists in those hot spring and those expression, now also those are similar temperature is coming out. And we have also concentrated in the Panamic area, which is north of the Leh. In this area is virgin area, except the hot spring temperature of the hot spring, there is nothing was known before this study. So in this area, we got some boreholes which were done by the state government of the Ladakh, and which is going up to 100 meter. And in the right side figure, we are showing the temperature profiles. We can see except in the few profiles we are getting normal temperature profiles, except 2 profiles we are getting, and those 2 profiles are in the near the two hot spring. One is Panamic hot spring, where temperature is around 75 degrees centigrade, and one is Changluk hot spring, where temperature is around 65 degrees centigrade. So after this study, in the NGRI, MT division and MT group and gravity magnetic group are also trying to study the north of Panamic up to 15-20 kilometer and south of Panamic 15-20 kilometer, total around 30 kilometer profile to know the subsurface of the structure of this area. And also geochemistry, hydrogeochemistry, they have studied the water in the Uga and Chamutang, and also doing the hot spring water in the Panamic. And in the workshop, they will present their studies, whatever result came. And for the sake of the our chief guest and guest of honor, we have made a poster session. After this, if you visit, you can see some result, whatever came till now. So this is our future need. So already we are in the work, and what our chief guest already explained, there were much to do, and he has explained the thing. So I think we should follow this thing, and we should come up with some output. Already he mentioned, so I need not have to mention this. So he has already mentioned about the whole world energy scenario. I can only focus that in India there is some power production plant in progress. It is around 20 kilowatt by GSI, and in that project initially we were also involved when they were doing the drilling. So we have measured the thermal properties of the rocks in those areas, and we have actually MOU. Yes, sir. And there are some direct heating also in the Gujarat. They are using in the small industries, and they are demonstrated a heat pump system also. Thank you, sir.
Thank you, ma'am. I now invite Dr. M. Satyanarayana to propose vote of thanks for the inaugural session of the workshop.
Very good morning to all. It's always an honor for me and a pleasant duty to propose a vote of thanks. Respected chief guest of the day, Padma Bhushan, Dr. V.K. Saraswat Saab, Honorable Member, Niti Aayog, guest of honor, Professor S.K. Mehta, Vice Chancellor, University of Ladakh, Padma Shri, Professor H.K. Gupta, President, Geological Society of India, and former Director, NGRI, Dr. Prakash Kumar, Director, CSIR-National, Professor Padma Shri VP Dibrisa, Dr. Sarolkar Saab, esteemed guest, distinguished guests, senior colleagues, staff members, students, ladies and gentlemen. On behalf of the organizing committee, I thank Padma Bhushan Dr. V.K. Saraswat, Honorable Member Niti Aayog, for taking his time amidst busy schedule, that too at the time when we have an international conference being held at New Delhi. And Niti, for taking his time amid busy schedule to be amongst us as chief guest for this workshop and for the excellent and vibrant keynote address. Sir, our sincere and deep apologies for the slight delay that has caused. I thank Professor S.K. Mehta, Vice Chancellor, University of Ladakh, for sparing his time, valuable time with us as the guest of honor for today's function and addressing the gathering. I also thank Padma Shri Professor H.K. Gupta, President, Geological Society of India, and a fatherly figure and a mentor for NGRI family, for gracing this function as guest of honor. Thanks to Padma Shri, Dr. V.P. Dibrisa, and distinguished guests gathered here. I sincerely thank our director for according permission to conduct this program and gracing this function. I thank all the invitees, participants, senior colleagues, staffs, and students for making this inaugural program a grand success. I also take this opportunity to thank the administration, technical faculties, including the IT group. Sir, apart from this audience, we have many watching us online. So youngsters. With this, we close the inaugural session here. and we will have a short break before we assemble for the next program in the same hall. Now I request all of you to raise for the national anthem. Yes. So after this national anthem, we will go for a poster session. Jana Gana Mana Adinayak Jaya He Bharat Bhagya Vidhata Punjab Sindh Gujarat Maratha Dravid Uttara Vindhya Himachal Yamuna Jala Jala Kitaranga Tava Shubha Name Jage Tava Shubha Shisha Mange Age Tava Dayadhar Jana Gana Mangala Jaya He Bharat Bhagya Vidhata Thank you, one and all. We will now break for the poster session, which is just beside in the launch. Thank you.